My guest today is Daryl Ritchison.
I am the director of the North Dakota Agricultural Weather Network, number one. So I say that because I have a lot of experience in data analysis and instrumentation. And so not a lot of people have a background in weather instrumentation. And number two, I am the state climatologist for the North Dakota, for the state of North Dakota. So I also have that background with me. And people oftentimes ask me with the state climatologist role, what's the most important thing to you, or, what your job entails. And that part of my job entails quite a bit. But I always tell them that my number one priority to me as a state climatologist in North Dakota is the integrity of the climate data in the state. And so what we're talking about today is really something that happened with the airport in Fargo. And so it's KFAR as our airport code, one of the easier ones to remember because it's far, in Fargo on there. And something happened on March 7th of 2023. And I thought this was going to be such a simple fix, simple process. And I learned a lot. I learned a lot about the bureaucracy. And I'd be honest, I was really surprised by the end results in all of this. And so, at one point I did bring it to your attention, and I don't have huge following on Twitter. It's like 5,500 people because I really focus on North Dakota a lot in that, so it doesn't garner a lot of people. But you had retweeted some of my stuff, and I really just glad to be here to describe what happened. And how this is probably a more widespread problem than people realize in the United States, because airport readings, for good or bad, and mostly bad, are really the main climate data for much of the United States. It's not the co-op data per se. In Fargo, we have the second longest climate record in the state of North Dakota. It goes back to January 1st of 1881. And it was in Moorhead most of the time until World War II, actually, Fargo, Moorhead, so Minnesota side of our twin cities here. And then it moved to the Fargo airport. And I've never been a fan of airports being the climate record, but it is what it is. I mean, look at Minneapolis, St. Paul, that's still using that airport. Will Minneapolis ever set a record low again, ever? You have to be 10 degrees colder than a record, but the urban heat island, to set a record. They're just really bad climatic sites, but it is in Fargo. And so I want to maintain this record, and you'll see what happened. It's very frustrating as state climatologist to have this not being fixed.
So that urban heat island at the Minneapolis airport is very large. I was not aware it was that big.
Oh, it's humongous. I think it's easily 8 degrees there. I always joke of that. I don't think a record low will ever be set again in the Twin Cities. In the suburbs, yeah, but that's not the official climate site. So,
is the sensor anywhere right near the tarmac so that?
Yeah, you can. If you go on Google Earth, you can find it. It is really. It's almost as bad as the one in Las Vegas, which made the news this past summer. And I'm going to show you something about Las Vegas, which I think most people don't realize what happened this summer with that sensor there. But yeah, in the Twin Cities, it's you zoom in, you can find it on the tarmac, and it's really, really close. And you have to remember, especially in the Twin Cities with the number of planes, that, granted, the exhaust coming out of an airplane is literally over 1,000 degrees, but quickly, it goes down to much lower temperatures. But when you have that many planes flying by, and you also have to remember airplanes, even without the exhaust and the tarmac heat, is the airplane's constantly moving, keeps the air continually mixed up. And so because of that mixing, you can never get that cold air in the morning to really settle in to break record low temperatures very easily. Even Fargo has a very distinct urban heat island with their airport.
So I'm curious, and maybe you'll mention this in your presentation, but do they have the type of sensors there at the airport that measure the temperature every 1 minute so that a breath of just a little bit of warm air, of hot air from an engine might cause a record? They have that?
Well, by definition, temperatures are measured in 1 minute increments. So a high temperature would be the 3-second average samples in that 1 minute is generally the WMO standard for that. Wind outside of the National Hurricane Center is the 3-minute samples averaged to 2 minutes. And so then, but the gust of the day is the strongest 3-second gust with a sample, because most of the sensors universally do 3-second intervals. And so most of the reports, if you go and get the 5-minute sample from, say, Mesowest of KMSP or KFAR, any airport, that's usually then the average of those 5-minute samples for that 5-minute average. But again, the high temperature would be a 1-minute average is usually how it's done. And that's how NDAWN does it, for example. Our maximum is a 1-minute average of 3-second samples would be our maximum high temperature of the day. And most ASOS readings, to my knowledge, and reading how it's done, WMO standards is how it should be done.
Let's say 100 years ago at that same site where the airport is now, did they have different sensors, or how did they capture the maximum temperature then? Was it a human reading?
Min-max temperature is either using mercury or, of course, alcohol, one or the other. And when you're taking electronic samples, most people are aware of this, is it's an instantaneous reading. But when you're using alcohol or mercury, it takes time. If you had, and this happens a fair amount, you just get this little whiff of the warmth of the day, and it might last 3 minutes. And it was, say, 90 degrees that day. But if you would have a mercury or alcohol thermometer, that thermal expansion up the tube is not fast enough to really capture that in 2 or 3 minutes. So a 90-degree high today may have been measured at 88, say, just kind of making that up, but 88 or 89 100 years ago, let alone, of course, the land use changes, which are huge changes too. So it's not even close to apples anymore. One of the things about having my Mesonet is we've had stations for 30 years out in the middle of no man's land, for lack of a better phrase, for 30 years, and we don't really have those influences. We've had to change electronic thermometers, of course, slightly because of modernization and just different stuff, but generally the accuracy hasn't changed. So we get a much better representation of what's actually has occurred through time. And so we have sensors close to Fargo, which a lot of times I will use as, okay, what has happened in the last 100 years? Well, can't really use Fargo after this date because of the growth. But if we use just this sensor 10 miles away, you'll notice there's really not much of a trend at all through that time, trying to differentiate, especially land use changes a lot, and also, different use of thermometers, especially from mercury alcohol when we want electronic.
Have you been in touch directly at all with Anthony Watts or maybe Willie Soon about these issues that you're going to talk about here?
I have not. Anyone on that's going to end up watching this is more than welcome to do it.
All right. Yeah, I'm excited to see your presentation based on what you've already sent me.
So really what I'm going to talk about is Fargo, North Dakota here. There are a couple of other Fargos in the United States, and really talk about how the poor QA/QC procedures have impacted our climate record here. And, QA, QC means different things to different people, but I always look at it in weather is QA, quality assurance, is like you're making something, whatever you're going to make for supper or dinner tonight, you have all the ingredients. That's the preparation for what you're actually going to do. So good QA is monitoring your calibration, for instance, simple things like make sure if there's not a bird nest in the rain gauge before it rains. That's more starting off for it. Whereas quality control then is something that's already in many ways occurred. How can you fix that? And I right now, I will talk about it with our network, have over 200 stations. So there are some QC things that we look at, every single day that sometimes we have to make some adjustments because we do a lot of crop guidance. We can't have a missing day. So sometimes we do some estimates and such to make sure all of our crop guidance works. And just to give you a background, one of my jobs, this is NDAWN. the North Dakota Agricultural Weather Network. And pretty much all of these stations this way is 100% end-on. And then down here, we've worked in cooperation in that circle with stations with the Minnesota Department of Agriculture, and we're hoping to expand this network throughout the state. So we have 218 stations doing pretty much everything you can think of as a weather station would do. Plus, we have 12 rain gauge only sites. And again, I like to mention this as, you know, if you're ever traveling up here or need good weather data in North Dakota, we have some of the best. We do. Matter of fact, I asked Grok about end-on and X, and you notice Grok was very kind, saying that we are probably the largest true Mesonet, all of our sensors being the same around the United States. But you notice what Grok I circled, you know, end-on stands out for its extensive network of weather stations, making it one of the largest in terms of geographic coverage and station density. So just a little shameless self-promotion. This is what a lot of our weather stations look like. This is a drone footage. This, by the way, is an all-season gauge to measure snow in the wintertime, not the depth, but the liquid equivalency, often called the SWE, snow water equivalency in our gauges. So that's what one of our stations actually looks like. And if you're curious why people have weather networks like end-on, it's really in many ways, these are weather risk management tools. We're using weather data to predict the future. We can predict when a certain insect's going to come out, when certain crop diseases are going to form, for example. And so if you know that this is going to occur in the next couple of days, you can get a head start on it. You're not surprised. This all brings a very strong value proposition. Think of it as return on investment. And of course, our use extends far beyond agriculture, and one of them is maintaining a good climate record. So if you want to see our data, this is our main website that we're working on improving, but endon.info is mobile compliant, and much of the maps I will be showing you in this presentation are from endon.info. And if you're curious, if you have such a worldwide audience, Tom, that I thought I would show you if you've never been to North Dakota. You notice right here, let me pick a color that'll show up nice and clear right there. That minus 47 this past winter, tied. Endon, by the way, has been around since 1989. And so we have 30 years of records, and we add new stations every year. But that minus 47 tied for the coldest reading ever observed in Endon. And matter of fact, the other coldest was not when you think it was just a few years ago in 2019. So our two coldest readings have been just in the last 5 or 6 years in the Mesonet. And this is just one of our maps. This is as we were recording this. You'll notice cold fronts coming through in the north. So you can see a lot of differences. But just to show you the density of our network, how many stations we actually have. But let's get to really what I'm going to talk about today. This is the airport in Fargo, North Dakota. And so this is the main runway right here. This is the main runway. It's mainly a north and south runway. It's technically at 350 degrees or 170. And if you look very carefully right here, you'll notice there's a little notch in that field. That little notch is where the temperature sensor is for the airports. That's the KFAR ASOS. And ASOS stands for Automatic Surface Observation System that all the major airports generally use. So there's that notch again. Okay. Here is ASOS right there. And of course, just for everyone's humor, there's rocks on the bottom of the station, mainly so they don't have to weed it, which does not give you good climate data. The temperature sensor is on the far left right there. And this is tarmac right there. And this is not the main runway. That's the taxiway right there. And the joys of Google Earth. They, by coincidence, took a brand new image of this last year in 3 dimensions. And what I wanted to show you, and I'm going to show you this again, is this device right there. I got permission to put endon equipment right next to the ASOS to test it out. So anyway, we'll get back to that in just a bit. So that is that notch again. So endon, the North Dakota Agricultural Weather Network, has a station at North Dakota State University, which is right through here. And so what I have is a weather station, which we have moved very recently because it was getting too contaminated. So we moved it about a mile. But right through there is the Endon station. And you notice it's very close. And that's important here as I go through this conversation. So that distance right there is approximately 2 miles. Technically, it's 1.9 miles, if you want to be more exact, and 3 kilometers away. We have since moved our station over here to get a little bit better data and move away from some of the contamination of buildings around NDSU as the campus has expanded. But anyway, for this purpose, we have here, right there, is everything is comparison to, again, only a couple miles away. Now, this is actually from the National Weather Service, not me. Okay, they made this graph. Do you notice anything in this graph that's funky? Okay, now there's a couple of bad points here, which we will ignore, but notice the very strong consistency between Endon. This is the difference between Endon and Fargo. So Fargo Northwest is Endon, their graphic, and you'll notice, boom, right there, big jump. It all occurred on March 7th. And guess what happened on March 7th? Maintenance was being done that day. Okay, routine quarterly maintenance to ASOS was done that day. So you notice the jump. So again, you'll notice this is from the Weather Service. They did this analysis. I have similar analysis. There was only historically an average of 0.4 degrees. That's far more accurate than our sensors, really. Okay, notice what happened on that day, after which it jumped 2.6 on average. So rounded, it's like a 3-degree difference on one day. I would think this map alone would be enough. And you might think to yourself, well, Daryl, how do we know it's the airport? Why isn't it your sensor? Good question. I have like 8 sensors around my other sensor, all saying the same thing. So, it's definitely 100%. This is something that happened to the ASOS station in Fargo. So that's this is the daily average high. And this is just, it's right through here. Oddly, the Endon sensor, more often than not, was a little warmer than the airport a lot, mainly because of land use changes. We're closer to the city of Fargo. Fargo does have an urban heat island, believe it or not, very noticeable at times, can be as much as 10 degrees. And then we went from Endon. Usually if I was forecasting, I'd forecast 80 for the airport. I'd forecast 81 for Endon. So I'm a meteorologist. I've been forecasting the weather for 35 years. But magically, it jumped up to here. So that's really a good 3. And again, key word here is average daily temperature. And all the average here is max, min, divide by 2. Okay? So the basic average, not using the 5-minute reports. This is the minimums. And you'll notice that you can see this jump here, but it's much more subtle on this jump. So really the problem, and this is almost always the problems with thermometers, is they have problems with afternoon high temperatures, with heating of the day. And this is the problem a lot of times with all, say, electronic thermistors or thermometers, whatever, that you're going through time. But if we do high temperatures, notice, whoa, that's a really big jump. So our maximums were being contaminated much more so. So again, we have multiple sensors here. Magically on March 7th of 2023, there was a jump. And I brought this to the attention thinking that this would get resolved pretty quickly, and it never really did. But again, Fargo is the official climate site. So, okay, a lot of people, and I had this. Well, Daryl, what does a couple 3 degrees actually mean? Well, anyone will know that, climate change, warming of the globe is oftentimes just a degree and a half Fahrenheit or 2, depending on what scale you're using. And it does matter quite a bit. So this was 2023, so a couple years ago now. This is the number of 90-degree days. So this would be about 32 degrees Celsius for the folks using the metric for Celsius. This is a very common metric in the United States. How many 90-degree days did you have? Fargo, by the way, averages historically 14. 14 days is our average. So if you like cool weather, come join us. We rarely get above 90 here. Okay. Notice we had 15 in 2023, just perfectly, just an average year. But the sensor at Fargo is reading 3 or 4 degrees too warm. Guess what happens? 29. Now, 14 is average, so the 15 on here, very average year. 29 ranks extremely high on the record scale. This is a huge difference. Now, does that stick out to people watching this? Yeah, that sticks out like a sore thumb. So we have the jump, we have this, two very easy variables. So this is last year, 2024. You'll notice Fargo had 4. You would have to go back to 1942 during World War II to find a year with less numbers. That was a very cool summer for us. Notice Western North Dakota. That was a hot summer for those folks. That's a lot of numbers. And not in Eastern North Dakota. Notice a very distinct difference between West and East, why we have a Mesonet. But, of course, the airport was, until August 24th, still reading too high. So guess what? 9. Again, subtle, but when you're looking at 90-degree days, that's a big difference. So that was a big difference for us. So you'll notice this is a tweet on X now. I should call it a post. You'll be kind of complaining that you'll notice it was 99 degrees out at the airport. It's almost hilarious, very humorous how far off the sensor is. And so I'm the state climate office. So I go, well, we're not using this data. I mean, come on. It's really been bad. So if you notice this day, by the way, the 72 is a thunderstorm went through. So that state just cooled down. But you notice everyone kind of in the low to mid 90s right there. But this is what the airport in Fargo is reading. So our end-on sensor 95, by the way, I am also the official co-op observer in Fargo. My main responsibilities, though, would be snow. Airports can't measure snow. The Weather Service is in Grand Forks, not Fargo. So if you ever hear Fargo, North Dakota got X amount of snow, that came from me. But so I go to a park, my backyard, depending on the situation. My thermometer, because the National Weather Service, because I'm co-op observer, gave me an MMTS, a minimum maximum thermometer system. I was also 95 in my backyard this day. But again, 4 degrees different. Fargo has hit 100 degrees Fahrenheit, 38 Celsius, only a handful of times since the 1980s as we've gone through kind of this cooling trend. So hitting 100 is a big deal. We almost did it this day for a bad thermometer. So we need to check this stuff. And so if you're going to do QC on stuff, you really do this like plausible check, range and temporal time. So really, can we hit 100 degrees in January? No, it would get QC'd out as an example. Horizontal difference, you're 102, but a station 5 miles away is 92, and there's another station, all these stations around you are noticeably cooler. That sensor is probably wrong. So this distance or range weighted is really important, especially for us. But these are just 3 of many. If anyone's out there listening, there's a lot more than this. But there's step changes like, wow, it was 90 degrees at noon, and then at 1 o'clock it was 82. Is that, that's a big step change. Stuff that gets flagged a little bit. We usually use about 5 or 6 degrees Celsius, because everything's done in Celsius, to just, was that actually accurate? But these are different step changes. But the thing is here, all of this is difficult if you only have one sensor. And that's the key here as we move forward. So this is from the National Weather Service. Tom, I sent you this slideshow. One of the things I wanted to show you here is they'll use stations out to 500 kilometers. For your imperial system people, that's about 300 miles away. Boy, did I show you that North Dakota map? It's tough to use that stuff. I be honest, I do not know this factually, but I think because Fargo is an ASOS, Most of the smaller airports in North Dakota uses AWOS system, which is automatic weather observation systems. Those do not have all of the equipment that a major airport ASOS will have, number one, and they're generally not quality controlled as well. FAA or local folks will control the AWOSs, the smaller airports. The Weather Service, say NOAA, as well as the FFA will deal with the ASOSs. And so to get the data, it gets really frustrating because Fargo's unique, and that's why we were able to catch this. Number one, we have NDON. So we're surround Fargo with 10 stations within like 50 miles, number one. Number two, we have a sister city, Moorhead. Moorhead has an airport, and Moorhead has an AWOS system, okay? It has its problems. I won't tell you about the dew point record in Minnesota being fake. But anyway, from this lesson, but notice this is back in the 2022. Notice kind of 50-50. This is high temperature difference. And you'll notice right there, the bias was only 1/10 of a degree. All right. Let's jump to 2024 when the airport Fargo, and again, these two stations, as the bird flies, are just under 10 miles or about 15 kilometers apart. Very close. Notice all of a sudden the bias went to 3 degrees. Okay, this is an AWOS, but again, more data to support that there's something wrong at Fargo. Remember this I showed you? National Weather Service, Airport Authority allowed us to go up to that, and we installed a stick station. And what this does is it's 2 temperature sensors. Was all that was on there. Because again, verification 2, a little tiny solar panel and a battery to run this little station all summer, okay? We did this from this past summer, from about May through August. And you will notice, so stick station 1, stick station 2, again, right next to the airport sensor. And then this is Fargo NDON 2 miles away. And you will notice, you know, a couple of degrees, which matters. Okay, for average, but remember, it's the high temperatures that were the biggest problem. Now we're talking, 2.5. Again, everything's rounded, so you almost can call this 3 degrees at times. And we're right next to it, okay? So this was my way of going, hey, I'm not crazy here. This is proof. And this was actually accepted as true, valid data. Here's another way of looking at it. You notice this is just May and June as an example. And you'll notice KFAR, how much warmer, and this is all in degrees Fahrenheit, how much the temperature max here over the actual average temperature. So HMP1, HMP2, HMP we use by SALAS, HMP 155s, which is the National Weather Service and ASOSs are moving to. The Oklahoma Mesonet uses this sensor. The New York Mesonet uses this sensor. NDON uses this sensor. Very reliable sensor in time. Now, this is from ASOS. Okay? Notice the air range. Okay? They will claim that, well, Daryl, this fell within 3.6 degrees air, therefore it met our standards. So even though it's different than it was or different than your sensors, it still met standards. I'll be honest, Tom, I've been confused forever by this because look at the range from minus 58 to 122, which is, 99.9% of the time of your temperatures. Only a few spots would get outside of that range ever. It's 1.8, but they constantly told me 3.6. Well, it was outside of the 1.8, but it was in the 3.6 because the average was around 3. But they said it always met their range test, so it's fine. Well, examples, these are all AWOSs or ASOSs. Fargo's 29, notice 27, 24, 20, all these temperatures 2 or 3 degrees cooler. No surprise, just a couple of examples. It's hard to see, but Fargo right there is 41, 39, 37, 37, 37, just these are other sensors nearby that their range test should have cleared off, but it didn't. And so if we look here, so most of the Weather Service originally used this sensor, the HO83. And if you're, you should do a Google search on this, folks, and you will find, whoa, wowza, was that a bad sensor? And I don't know if they ever fixed some records that were broken because of the horridness of that sensor, but this sensor right here. So I was curious. I asked Grok about these sensors, and Grok said that what he said was, well, these aren't being used anymore because they're old and they should have all been replaced by now. I hated to tell Grok that it was wrong. A lot of these sensors are still out there. Here's the thing. A lot of these sensors, what I've been told, and this was true at Fargo, have been out in the field for 20 plus years. I run quite possibly the largest Mesonet in the United States that all has the same temperature sensor, same equipment. Wow. If we go 3 years without replacing a sensor, I'm mad. Our standard is 1 or 2 years replacement and recalibration constantly, yet they will have sensors out for 20 years. They just have to pass a test. And what happens is, and there's some research on this, is when these electronic thermometers, through time, they will gradually have this warm bias. Well, 1 or 2 degrees bias again, if you stepped outside, is it 80 or 82 today, you couldn't tell the difference. But we all know a degree or 2 really matters. Remember the problems Las Vegas had this past summer? May recall, breaking some records, horribly placed. Guess what they did? They replaced it with an HMP 155E version, but they're all the same. We have multiple of these 155 versions out in the network because they change them all the time. They were replaced in both Reno and Las Vegas on September 4th and Fargo. But there's a lot of these sensors still not out there because it's this, well, I was always told it's not in our budget to replace these. And truth be told, ASOSs and AWOSs are meant for aviation safety. And I'd be the first one to say they do a great job in aviation safety, because 1 or 2, 3 degrees doesn't really make a difference much. It does when you get to a certain temperature in Phoenix, but generally speaking, it doesn't. Being 2 or 3 degrees off really isn't a bad thing. They do what they do good for aviation, but they're horrible climate sites again. So again, some of you might remember some of the records in Las Vegas. It's horribly cited, even worse than ours at the airport. But they did replace that sensor. So this is the letter I got from the National Centers of Environmental Information and said, Daryl, sorry, but we're just not going to replace it. Well, the one thing here I want to circle is this statement right here. Okay, to intervene when a record is meeting the defined standards, when no other extenuating circumstances have been found. I gave you a lot of extenuating circumstances why this sensor is off, and all of the climate records from March 7th of 2023 through August of 2024, for 18 months almost, were wrong. All I wanted to do is, could we replace those days with end-on data from the airport just 2 miles away, 3 kilometers, to maintain the integrity of the data in Fargo, because it's the second longest data, and really even nationally to have records 1881 is fairly rare. But of course, I in turn was turned down on all of that, and everything is done, even though it says 1.8 and they were using 3.6. So that is what happened in Fargo, Tom. And as a state climatologist and really trying to maintain the integrity of the data, I was very disappointed. The State Climate Office uses end-on data, not the airports. So we have, for our records, but, NCI and really what most people find, of course, are not, they will use what they find on, ASOS and things like that. So it was a very frustrating bureaucratic stuff. They test, they know about this 2 degrees constantly or 3 degrees. but because it met their standards, and one of their standard tests is to just using a fluke. And if you don't know what a fluke is, it's Fluke. Look it up. It's just a device that measures temperature. It's usually a handheld device, but they generally aren't all that accurate, within a degree or so Fahrenheit. And because you're taking it out of a car, you're taking it out, you're sticking it next to the ASOS thermometer and looking, going, oh, ASOS says 83 and I'm saying 81.5, it meets specs, move on. Well, it takes time because you can't take a temperature measurement in 5 minutes. We bring our stuff in, calibrate it professionally, make sure it's accurate. And so this something very similar had happened at KBIS, which is the Bismarck Airport, back in the summer of 2021. They said it same thing. I know it was reading 3, 4, 5 degrees too warm by any common sense. It is so hard to test this because 2 degrees matters. Again, it's so hard to test. We were able to prove this at Fargo because of Endon and to some degree the Moorhead Airport. Bismarck, we have a sensor a few miles away, but it's a different elevation because Bismarck's in a Red River Valley. But it was way different. The co-op observer, other backyard thermometers in Bismarck was wrong, but it was harder to prove. So I've gone around the United States and used Mesonet data and other data, and I have discovered a lot of times the same discrepancy of a degree or two, but some of it easily can be blamed on it's at an airport, land use changes, tarmac, those reasons. But sometimes I just look at it and think, I wish I had enough time to try to do a better long-term analysis, because my suspicion is, forgetting the tarmac, the poor sightedness of this, that probably a lot of these ASOS stations are reading a little too high. But it's so hard to prove it because when you distance weight it, there's really nothing close enough to do it. Because again, Fargo at times can have upwards of a 10-degree urban heat island impact. So it's a long term, and you have to be careful in how you do that research. If your audience, anyone, had the time and wanted to see it, it's a tough one, as all temperature data is, to really get down to the nitty gritty. What's a temperature error, what's land use changes and stuff. But again, my strong suspicion is this is more widespread than just what happened in Fargo.
Do you think there are people that are happy to use maximum temperatures that are too high because of the whole global warming thing? Or you don't think that is part of it?
I've been asked that a lot about this, Tom. I honestly believe it's more of a bureaucratic problem. And I really think Fargo, if it was reading 2 degrees too cool, I would be just as frustrated because it's still integrity to me. And I still don't think it would be fixed. I know people are listening, and people have asked me about this just thought I was crazy to think that way. But the bureaucracy is the bureaucracy. And, the standards, in a way, to me, I thought were being used wrong based on, they were saying 3.6 when it says 1.8 in that certain temperature range. But, I don't know the answer to that, Tom. I just really think it's more of a bureaucracy problem. And I don't think enough people really care about the integrity of the climate data. And it's just, something, as even before I was state climatologist, I always cared. I wanted it as accurate as possible.
What are your thoughts on this whole idea that some certain year set a global average temperature record by 0.03 degrees Celsius?
Well, statistically, it's just crazy. I mean, it's well within the bounds. You just can't really do that. So I always kind of just roll my eyes when I hear that stuff, because 3/300ths of a degree. I generally, most thermometers are only accurate to, say a 0.5 degree Celsius.
Okay, I'm just trying to find this quote from NASA. Oh, yeah. At one time, NASA said on their website, for the global mean, the most trusted models produce a value of roughly 14C, i.e. 57.2F, but it may easily be anywhere between 56 and 58F. So they were admitting that there's quite a bit of uncertainty in trying to figure out that number, right?
Yeah, and the reality is that number is probably even a little bit greater than that.
Okay.
A little bit. I'm sure it's pretty reasonably close, but I would say it's probably plus or minus 2F for a good solid 1 degree Celsius, 1.1, 1.2 degrees Celsius. But I mean, there's people a lot smarter than me that would argue with me both ways, and that's fine. To me, it's always the joys of being a scientist, is going through the scientific method, step by step and seeing, and then if your hypothesis is not perfect, you go back and start it all over again. And I'm one of those people. If some of the things I said today, which again are all the opinion of me, as Daryl Ritchison only, and gave me some good proof on some stuff, I would accept it very readily. I think I have a very open mind on all of that.
Do you want to talk at all about this fake dew point thing in Minnesota? It's very intriguing that you brought that up.
Do you know what the state record is for the dew point in Minnesota, Tom?
Nope, I do not.
Type it in.
Okay.
Do it good.
Let's see. Record state dew point on the Minnesota DNR website talks about in 2011, 88 degrees Fahrenheit.
And where was it?
Moorhead Airport.
Yeah.
Police station. Okay.
There. I kind of knew that. If you go back and look at a time series, that AWOS, and I think at the time I was using an HMP 35C from Vasala, decent sensor for the time, but it was always reading 3-4 degrees too high for its dew point forever. You just kind of ignored it as a working in the television market here. And there is an end-on station about 4 or 5 miles away that was more like 83-ish, very high. Don't get me wrong for our climate, very high for our climate. And I do believe from memory, Fargo was 83. I was working the morning shift, Tom. I drove out to the airport in Moorhead. It's right on the interstate. You just take an exit and it's right there. And right next to that AWOS station, I took a sling psychrometer. And guess what I measured the dew point to be? 83, just like the other ones around it were reading. And so then I waited a while, put a new little dry sock on the thermometer, let it reset it to itself. I think the temperature that day was like 92, 3 or something like that. Waited a while, reset things, went back and did it again. Because you always verify. And I got 83 again. And I did send a note to Minnesota that it was not. That was a bad sensor, but they did their testing and everything. I said, no. Okay. But what can I do? I verified that it was wrong with the sling psychrometer, all the rest of the stuff. But again, they go take these tests and it meets their specs within whatever. And I've always just, I did my best, but trust me, the dew point at that time was 83.
Yeah, so they blessed that record, and it was too high by 5 degrees F. Amazing.
Yeah. And if you look back through time, that dew point sensor was usually off. You can download it off of, especially NCEI. You can find, and if you do a trend do 2010, all of 2011 for 2 years, and you'll notice that dew point temperature is always 3-4 degrees Fahrenheit, a lot of times 3, higher than anybody nearby. But again, integrity of the climate data.
Have you done much investigation of other, fancy all-time record sets in other areas in the world? Or do you have suspicions about maybe Death Valley or whatever? Anything else?
I have. The thing is, I am so busy with North Dakota. I really wish, I'm in my 60s now, and I always go, what am I going to do when I retire? Jack, I have always been a weather data nerd, even when I was very, very young as a teenager. And it was so hard to get data, actually, back in the day. I remember getting a floppy disk, folks, with weather data on it, because the nice thing about weather data, it's just text. So you can put quite a bit, even on a floppy, a megabyte. But I used to always play with numbers, and I love playing with numbers. One of the things I'm trying to do in North Dakota as state climatologist is really verify some of these old records. Did this actually happen? Let me see it. Was it a typo? Was it an error? What's the circumstances around it? Because I just want to make sure, verification and really the integrity. I want, in my tenure as the state climatologist, as everything in the state to have been looked over and do due diligence. Is this actually something that we should use?
So are you feeling any pressure that you shouldn't do your job the way you are doing it because it's politically incorrect to actually look at the data and find problems? Is that a problem for you?
No, I mean, I don't know how to say this. And I will remind people, it's my own opinion. No one else is here, but it's North Dakota's really good about this. It's just it's a state where I think there's a lot of open-mindedness, and I really have not gotten any negative feedback at all. And any feedback I do get is usually positive. Good for you, glad to do it. I was interviewed on our public television station in North Dakota a couple weeks ago. Some of this came up in it, and people just go, "Wow, that was one of the best conversations I've ever heard about these things. Thanks for sharing." Just bringing stuff out there one way or the other. So maybe it's different for other folks, but for me, I've always been very positive, and I'll be honest, I'm very thankful. I know other problems that have occurred out there. I get complaints about things. The state climatologist, one of the things I work on is the drought monitor, for example. And that thing, it has a lot of flaws. We try to do our best on it. And I had a call this morning. I explained to them what happened, why this occurred, what I'm personally working on, for example. So all jobs has positives and negatives. But again, most of my feedback has always been positive.
Based on what do you think that the summers in the 30s and 40s in North Dakota were hotter than anything we've seen since then?
Yes, especially in the 30s. But you have to remember, one of the reasons there, I'd always say this, we've been nowhere close to that stretch. That stretch in July of 1936, there's, a lot of people call them, black swan events. And that would be a black swan event. I don't like that phrase because there's actually a species of black swans. I call them white bison events because white bison are very rare. And plus, I'm in North Dakota, so we're the bison state, or at NDSU, the bison state. But we had so much soil blown around, covering everything, and we all know just specific heat. That little layer of very dry soil heats up very, very rapidly. And so some of that they're certainly natural, but man-made causes of the Dust Bowl, because if we hadn't plowed up the prairie, those same days probably would have been 108, 109, say, rather than 100, 115, 120, just because of all the dry soil exposed over so many surfaces that were really, really dry. But oddity here, Tom, most people don't know this, but North Dakota ranks number 5 as the 5th warmest state in the sense of all-time state records. So our all-time state record in the 1930s was 121. So that ranks number 5. So I always tell people, you might think North Dakota's cold, but we are the 5th warmest in state records.
And how close have you been to hitting 121 in the last 20 years, let's say?
Generally speaking, this past summer, we had an NDON station at 111. All those 90s out west, it was just, 10 days of very high temperatures, very dry soils out there, but really about 110 since the 1930s, ish, 110-ish, is about as warm as we get here. And it's been occasionally. Before 1936, the record in Fargo was 110. And it was a dry summer, and we just had, that 1 or 2 days that just happened to get here. I mean, it's just part of the climate of a continental location like we are. You just get these, really strong extremes. But really, yeah, it's been about 110-ish again, about as warm as we've been since then. And to me, I'd be surprised unless we have a really long dry spell, 3 or 4 year drought, to really dry things up enough that we could surpass 110. I'm sure at some point in the last 1,000 years, something similar has happened, for example. It just takes a long-term drought to do that. And really, most of the United States hasn't had a long-term drought since the 1980s. It'll happen at some point, and we'll see how high the temperatures get.
So if people have follow-up questions for you, I'm going to put your Twitter handle in the show description. Is that a good way to contact you?
It is. And if you'll have my name pop up. It was on my splash screen that they can go back and capture. My email address at NDSU is my first name dot last name at ndsu.edu. So it's Daryl.Ritchison at ndsu.edu. People are very welcome. Sometimes it might take me 2 or 3 days at times. Besides being the director of NDAWN and the state climatologist, I also teach at NDSU weather classes. And so sometimes I fall behind a little bit, but usually I will get back within a few days of the emails.
And would you be okay with sharing your slides as a PDF so people can look at your slides on my Substack?
Yes. Do you want me to send those to you, Tom?
Yeah, if you would, then I can put them up.
Oh, yeah. At least that's some of the stats. And my name, again, is on there so people can get a hold of me if they would like.
Very
or
good.
follow me on X. But again, I mostly post on North Dakota stuff.
All right. Any other points you'd like to make before we finish up here?
No, I just really appreciate your you asking me to be on this. I'm glad I've given a few other much shorter little presentations on this. It's just trying to get the word out in some ways of, my passion is integrity of climate data, how disappointed I was with the bureaucracy and NCEI and the way, this was handled on this climate record, which of course raises, my ears a little bit. My Spock ears might pop up a little bit as, is this happening elsewhere? And if other people have more time and look into that, I'd love to hear about it.
So just as an aside, do you have ideas as to what the title of this podcast should be to sum up what you said here? I can think about it.
Oh, I'm terrible at names. When I give a lot of public talks around the region and even in the United States, so I'm speaking a lot. And they always ask me about the title, and I always fail, I think.
All right. Okay.
So I'm not going. Maybe you could use Fargo in a weird sort of way, far away to go to get the temperature record fixed or something like that. Because it was a long 18-month battle.
And actually, you did get it fixed. I wanted to make sure that there's a good sensor there right now.
The sensor right now is back to where it used to be. And honestly, I probably should have done a graphic. They did put an HMP 155 version E out at the airport. And ever since then, it's back to that, 1 degree long-term trend that we've had before. Every thermometer has quirks. And anyone that's a forecaster out there knows this. I don't forecast the weather. I forecast an airport sensor. If you know that, for instance, Fargo-Moorhead is a very long, narrow city right along the river. We're about 10 or 11 miles long. I'm the co-op observer. Only thing that's really used, and you can look me up, I'm Fargo 3S. If you go on NCEI, if you go into ASOS, I'm Fargo 3S. So Fargo 3 South. And if it's a south wind in the wintertime, a lot of times high pressures come overhead, and then all of a sudden the wind will shift to the south. All the heat from the Fargo, like 10, 15 miles, will float over to the airport, and the airport might be minus 12. I'm in South Fargo. South of me is nothing but open farmland. And all of that air flows into me. I'll be minus 23, and the airport will be minus 12. North wind, the exact opposite happens, though. Fargo might be minus 23. All the heat floats over my house, and I might be minus 14. So it's this huge, urban heat islands. I think sometimes they're much bigger than people realize, because Fargo, if you've ever been up here, is not a very big town. Like say the Twin Cities or Chicago or Dallas, Fort Worth, et cetera, et cetera. So it's very interesting. And that stuff, just to be honest, just fascinates me. I've been a weather nerd, about this stuff since I've been 5 years old. And so even, human impacts, anything, having the Mesonet, this elevation here, little mini Chinook winds that form off of buttes in North Dakota. there's so much fascination with weather, and I just, it's that nonlinear chaotic system, the atmosphere, to me, it's just never ends in my fascination after all these years.
All right. Thanks for your great work. When I started this podcast, I was hoping to have people like you give talks like this. So great stuff. Thank you.